In the previous video, we set up our PID loop. Now we're going to set up the PLC's analog I/O for PID and transfer the PID configuration to the PLC. This PLC has analog I/O built into the CPU, so we go to Setup, CPU Built-in I/O, and click on the Inputs tab. Our sensors generate 4 to 20 milliamps, so we want these. Our sensor's range over the 4 to 20 milliamps is 0 to 300 degrees, so we put that here. Now everything we do will be in degrees Fahrenheit. We need for the raw process variable to end up where? Well, if we go look at the DF memory and scroll down to the 100 block we allocated, we see the raw process variable needs to end up in DF111, or 12 memory locations from the start of whatever memory block you specified, so we put that here. The room temperature sensor is identical, so I'll do the same thing here. Now watch out for this. The Click software automatically put the next DF register for our room temperature sensor here. But if I unselect this continuous address thing and go look at the DF memory again, we see that the DF112 address is reserved for the filtered process variable, and we really don't want to overwrite it with the analog input, right? So let's change the analog input to write to DF1, which I've already named room temperature. So if you're using PID, it's a good idea to just turn this off, so if someone comes back later and adds another analog input, they won't accidentally overwrite your PID configuration. Range limiting is on by default. That'll issue an error message if things go beyond what we expect. That's a good thing, so we'll leave it enabled. And hit OK. Where are we? We've configured PID, and we configured our analog inputs. And look, we're done, and we have no ladder code. We just add an end instruction, connect to the PLC, and transfer the project to the PLC. I'm going to assume you know how to do that. Well, great. Now that we're connected to a PLC with a configured PID loop, we can double-click on the new PID monitor that was automatically created for this loop. I love this dialog because I can see at a glance everything I need to know about my PID loop. And right now, it's telling us something really important. If you look at all of these values, the right-hand column is what's in the project, the left-hand column is what's in the PLC. Do you see it yet? Yeah, even though we transferred the project to the PLC, none of the PID configuration values have been written to the PLC yet. Why is that? Well, because you or someone else may have tuned the PID loop after the last transfer without saving it to the project, and you probably don't want to overwrite that. So by not automatically writing the PID configuration values on project transfer, you're forced to manually write those values yourself, which gives you one last opportunity to stop and think, have I made any changes to my PID configuration? And if so, do I want to save it before overwriting it? There are some buttons here for reading and saving values shown on the screen here, but they only write the parameters you see here. They don't read and write all of the other PID configuration parameters. Now you could force all of the values individually via a data view or program them into your ladder code, of course, but we haven't done any of that yet, so the only way to read and write the PID configuration is to go back to the PID setup. If you look at the previous video, you'll see that there were some buttons to do that, but they were dimmed out because we weren't connected to the PLC. Now that we are connected to the PLC, we can exit the PID monitor and go back to the setup dialog where we see the read and write buttons are now enabled. So the best way to make changes to your PID configuration is to read all of the configuration data from the PLC, make your changes, and then write all the registers to the PLC. That'll preserve any changes made since the last transfer. And since these buttons are outside this box, they affect everything inside the box, which includes all of these tabs. Now, we don't want the PLC values to overwrite our new configuration we set up, so we're going to skip reading the values and overwrite all of the PID setup configuration registers to the PLC. Now, these values are both in the project and the PLC. Now, if we go back to the PID monitor, we see that the project and the PLC values have been updated, which is a pretty good reminder that we updated all the others too. Suppose we got some new tuning parameters here. I'll just enter some random numbers for now. And we want to enable filtering. Well, we can't because it's currently disabled. So we need to close the monitor, go to the PID setup, and before making any changes, read the current values. You can see here it pulled in the new tuning coefficients that I just entered. Now we can enable process variable filtering and then write all of the values back to the PLC. So reading the PLC values first preserves the new tuning coefficients and puts them in the project so we can save them for future transfers. If we go back to our PID monitor, sure enough, the process variable filtering is enabled, and we see that we did in fact preserve the tuning coefficients. Now, I hate spending so much time on reading and writing values, but it's really important that you understand that the PID configuration values are not written to the PLC with a project transfer. You have to do it via the setup dialog, or via ladder, or via data view. Okay, enough of that. Let's get back on track. The first thing to notice is we're in manual mode. It's important to understand that the PID math is running all the time, and normally it automatically controls the PID output. But we can disconnect that and manually control the PID output so we can force the PID output to whatever value we want. You'll see how handy that is in the next video when we characterize our system. These guys switch us between those two modes. Our PID system is now set up and ready to use, so join me in the next video where we'll characterize our system by manually manipulating the output, do an auto tune, and then run a bunch of examples so we can see how well PID works in the Click PLC. Click here to see all of the videos in this series. Click here to learn about Automation Direct's free support options, and click here to subscribe to our YouTube channel so you'll be notified when we publish new videos.